Hello students, in this video we'll see an example of how to solve a non-homogeneous constant coefficient differential equation. Let's consider y double prime minus y is e to the x minus 4. So to solve this problem, we write this in our differential operator notation as d squared minus 1 applied to y is equal to e to the x minus 4. And we need to figure out how to annihilate both e to the x and 4. So we note that the right-hand side is d minus 1, the left-hand side is d minus 1, d plus 1 applied to y is e to the x minus 4. And then we can annihilate e to the x with d minus 1 and 4 with d. So if we have a d minus 1 and d, if we add those to the left-hand side, I'll have a d minus 1 and d plus 1 applied to y is equal to d minus 1 d e to the x minus 4. And the d minus 1 will annihilate the e to the x, and the d will annihilate the 4. So this will be 0. So our ODE has been converted to a homogeneous one that has the form d minus 1 squared d plus 1 applied to y is equal to 0, which has a general solution. Y equals c1 e to the x plus c2 e to the negative x plus c3. Now I have 2 of the d minus 1, so I get a c3x e to the x, and then a c4. These terms over here are the homogeneous solution, and these terms over here will comprise the particular solution once we know c3 and c4. So we plug in the particular solution and check. Plug in particular solution to find c3 and c4, which are our undetermined coefficients. So let's call this particular solution y sub p. So y sub p prime will be c3. And then the derivative of x e to the x is found by the product rule. It's x e to the x plus e to the x by the product rule. And the derivative of c4 is 0. Then I have y particular double prime is going to be c3. Then again, I'm going to have x e to the x plus e to the x plus the derivative of e to the x is e to the x. So this is going to be c3 x e to the x plus 2 e to the x. And now we plug this back into our original problem. So y particular double prime minus y particular has to equal e to the x minus 4. Y particular double prime is c3 x e to the x plus 2 e to the x. And then minus y particular is minus, y particular is found over here, c3 x e to the x plus c4 is my y particular. This has to equal e to the x minus 4. So what we have over here, when we simplify this, we notice that the x e to the x terms are going to cancel out. And so the left-hand side is just going to be 2c3 e to the x minus c4. And this has to be equal to e to the x minus 4. And so comparing these coefficients over here, we see that 2c3 is equal to 1, and c4 is equal to 4. So c3 is going to be equal to 1/2, and c4 is going to be 4. So we can now write down the solution to our problem. The solution to our problem is the homogeneous part, c1 e to the x plus c2 e to the negative x, where c1 and c2 are arbitrary constants, plus c3, which we have found to be 1/2 x e to the x, plus c4, which we found to be 4. So over here we have our particular solution, y particular. Over here we have our homogeneous solution, y homogeneous, and we have solved our problem. Thank you very much.